Hello and welcome to Hoopla Kids Lab, making science super fun and super simple. In today's awesome experiment, we're going to show you copper electrolysis. You're going to need a stirrer, some clip test leads, a pair of gloves, copper sulfate, a piece of brass, a piece of copper, a D battery, and a beaker full of water. The first step is to pour some of your copper sulfate into your water and dissolve it in. The best way to do this is to add a small amount of powder at a time until no more will dissolve. This will turn your water a very bright blue. Make sure to stir the mixture thoroughly. Place that to one side. Then take your D battery and some of your clip test leads. Clip one end of your lead onto the copper and then carefully tape the other end onto the positive side of your D battery. Then take your piece of brass and use a clip to attach that to the negative side of your battery. The negative side is usually the flat end of the battery. Once that's done, we're ready to go. Rest your stirrer on top of the beaker to stop your piece of metal from falling in. It's also very important that the clip leads don't go into the solution, just the two pieces of metal that they're attached to. You can see that our piece of brass and our piece of copper are sitting in the solution but not touching. Now all you need to do is leave this to sit for about half an hour. You won't be able to see anything happening, but once you remove the metal from the solution, you'll see that something has. Some of the copper has transferred to the piece of brass and plated it. This is because the current flows through the battery into the leads, then through the copper, and is attracted to the piece of brass. The liquid completes a current, which allows the electricity to flow, producing a reaction we call electrolysis. The silver egg illusion. For this experiment, all you're going to need is a pair of tongs, an egg, a glass of water, a lighter, and a candle. The first step is to take your candle, take your lighter, and light the candle. Make sure that you have an adult present when you're doing this. Once the candle is lit, you're ready to go on. Take your egg and hold it carefully using the tongs. Hold the egg just over the tip of the flame. You will need to get the egg nice and close to the flame to make sure this works. When you're close enough, you'll see that a thin black layer of soot forms around the outside of the egg. Do this all the way around the egg, coating as much of it as you can in a layer of black soot. Once that's done, take your glass of water and slowly place the egg inside. You'll see that the egg suddenly looks like it's made of silver. Well, this is actually because the soot that coats the outside of the egg is really a thin layer of carbon, which repels water and holds a very thin layer of air around the outside of the egg, making it appear silver. The areas not coated in soot look completely normal. Isn't that amazing? It's a great illusion to show your friends. Why not have a competition and see who can make the most amazing looking egg? And there you have it. That's how you can perform the silver egg illusion. Bubble inside a bubble. This is a fun little experiment. You just need a spoon, some scissors, a glass of water, a pipette, some granulated sugar and dish soap. Take your glass of water and mix in a tablespoon of sugar. Then add 2 tablespoons of dish soap. Mix this in thoroughly so that you can no longer see the sugar granules. This might take a bit of time, but just be patient. Place the mixture to one side, dip your fingers in the glass, and rub a small amount of it over your surface. This will help you to make the bubbles. Then take your pipette and very carefully use the scissors to cut off the end. This will help you blow your bubbles. Dip the end in and very carefully blow a bubble on the table. Once that's done, dip it in the mixture again, carefully push the pipette through the bubble and blow another one on the inside. And you've got a bubble inside a bubble. The washing up liquid helps you make bubbles out of the water, but the sugar helps those bubbles to be really strong. The aim of the game is to see how many bubbles you can make inside another. It actually gets quite tricky because the surface is very slippery and so the bubbles move around whenever you blow. As you blow a smaller bubble inside the original bubble, it simply pushes the air outwards, making the original bubble grow. It's a really cool effect. It's quite tricky to get the hang of, but once you do, there's no reason why you couldn't make 4 or 5 bubbles, one inside the other. And there you have it. That's how you can make bubbles inside a bubble. Cloud Rings Launcher. All you're going to need is a box of matches and a water bottle. Make sure that there's a small amount of water in the bottle. Then light the match, squeeze the bottle and carefully let it go. This will suck the smoke from the matches into the bottle. Then very carefully open up the cap and squeeze. If you look up, you'll see that the smoke forms into rings. This happens because the cap of the bottle is in the shape of a small perfect circle. This means that as the smoke escapes, it takes the form of a ring, as the air escaping from the bottle is in a perfectly round shape. You can play around with this and try to create rings of different sizes and thickness. Why don't you see how high the rings can go before they lose their shape and disappear? Why don't you try different size bottles or different size caps? And there we have it. That's how you can perform the Cloud Rings Launcher experiment. How to boil water with ice. For this experiment, you're going to need a chopping board, a thermometer, a frying pan, a glass bottle with some water inside, a glass, and some ice cubes. The first step is to place your pan on top of the hob, put your bottle inside the pan, and then turn on the gas. If you have an electric hob, you don't need to use a frying pan. You can just place the bottle directly onto the hob. The water will heat up and start to boil. Once it reaches boiling point, carefully remove it from the pan and screw the lid back on top. You'll see that the water is still bubbling. Place your bottle upside down inside the glass. Then place a few ice cubes on top of the bottle. you'll notice that the water has stopped bubbling. But when you place the ice on top of the glass, it will start to bubble again. Keep your eye on the water. You'll see that as the ice sits on top of the bottle, the water starts to boil again. This is because the ice on top of the bottle cools down the air inside. This reduces the pressure and lowers the boiling point of the water, meaning that instead of having to reach 100 degrees Celsius, it only has to reach a lower temperature in order to boil. So you're literally boiling water with ice. I think that's pretty cool. The ice will start to melt as it's on top of the bottle, since the bottle is warm. If you like, you can replace them with fresh ice cubes to keep the experiment going. We let the water boil for a while, then turn the bottle back the right way up and measure the temperature of the water. It was at approximately 70 degrees Celsius, meaning we got water to boil at only 70 degrees instead of 100, which is pretty cool. And that's how you can boil water with ice. Fibre optics. This is a great experiment. You're going to need a laser pen, 2 bottles of water, a plastic container, some food colouring and some scissors. The first step is to open 1 bottle of water and put a few drops of food colouring inside. Screw the lid carefully back on and shake the water a few times to mix the colouring in. Once that's done, take your second bottle of water, unscrew the lid and empty the bottle. You can do this in a number of ways. I chose to just drink the water. Once that's done, you can carry on. Screw the lid back on top. Take your scissors and very carefully cut along the bottom of the bottle. The easiest way to do this is to make a small hole using the point of the scissors and then to cut along. Make sure that you have an adult to help you with this part of the experiment. Once that's done, remove the cap and once again use the point of the scissors to carefully make a hole in the centre of the cap. The hole needs to be big enough for water to flow through it. Screw the lid tightly back on. Take your plastic dish, your laser pen and your 2 bottles. Unscrew the lid from the bottle with the food coloured water. Then carefully hold your empty bottle upside down with 1 finger blocking the hole. Pour the coloured water into this second bottle. Then take your laser pen and point it into the water. If you turn down the lights, you'll see that you're able to see the beam of light shining through the water. Hold it above the bottle and point it towards the hole in the lid, and then remove your finger. Once you do this, the water will start to drain out. You'll also see that the red light travels along the stream of water. Even though the water is curving, the light travels with it. But how does this work? Well, the stream of water actually acts like a fibre optic cable, which is a cable made of thousands of glass threads. These glass threads normally reflect light along the length of the cable. However, the water acts in much the same way. meaning that your light shines in a straight line until it reaches the end of the bottle, where it follows the path of the water in a curve. The water acts like hundreds of mirrors, angling the light down towards its own path. The food dye helps us to see the path of the light. And there you have it. That is fibre optics. Genie in a bottle. This is a great experiment, and you're just going to need a measuring jug, some manganese dioxide, a bottle, some hydrogen peroxide, a spoon, and importantly, safety goggles. Make sure that you have an adult to help you with this experiment. First of all, put your safety goggles on. Once you've done that, take your jug and your hydrogen peroxide, and very carefully and very slowly pour 100 millilitres of hydrogen peroxide into the jug. Once that's done, pour that carefully into your bottle. When you've finished, put your jug to one side, take your manganese dioxide and put a small amount onto your spoon. You won't need much for this experiment to work, roughly 1/4 teaspoon. You can see it's just a small, thin film of black powder. Screw the lid back onto your manganese dioxide and then very carefully drop the powder into the bottle. And hey presto, there's your genie. Now, is it a genie or is it science? Well, I'm sorry to say, it's just science. What happens here is the manganese dioxide is reacting with the hydrogen peroxide, separating it into its two ingredients, water and oxygen. This creates steam, just like when you boil a kettle, and this steam is then funneled through the neck of the bottle to make it look like a genie is emerging. This happens very quickly because the manganese dioxide powder is a catalyst, which is something that speeds up a reaction and makes it happen in seconds rather than minutes or hours. I think this looks really cool. You can see all those bubbles forming from the reaction. That's the oxygen escaping from the water. As they separate, they produce heat. That's why there's condensation on the inside of the bottle. And there you have it. That's how you can make your very own genie in a bottle. Ghost marbles. For this experiment, you're going to need a bowl, a pack of aqua gel beads, and some water. The first step is to open your packet of beads and pour them into your bowl. You'll find that these bounce around quite a lot, so do be a bit careful. Once that's done, take your water and pour it into the bowl. Keep pouring until all the water is gone. Then place the bowl to one side. Leave it alone for a few hours and come back to it, and you'll see that the water has been replaced by these. These are the same gel beads that were sat at the bottom of the bowl, but over time they've slowly absorbed all of the water. So what happens if we pour more water back into the bowl? The beads disappear. Well, that's not quite true. They don't really disappear. They're still in there. What's happened is that the beads have absorbed the water that was in the bowl. This makes them about 90% water so that they refract or bend light in almost the same way as the water does, making them seem to disappear. If you place your hand carefully inside the bowl, you'll see that you're able to scoop the beads out. They're much larger than they used to be. They're also very slippery. Looking at the bowl from above, it's very hard to tell the difference between the water and the beads. If you look very closely, they look a little bit like frog spawn. You can just make out the edges of the beads. Isn't that weird? It's easier to see the beads if you move the water. Isn't that crazy? And there you go. That's how you can make your own ghost marbles. Glowing liquid metal. You're going to need some pliers, a highlighter pen, ferrofluid, a pipette, a small dish, and a magnet. Use the pipette to squirt a small amount of the ferrofluid into your small dish. Ideally, you want to just about cover the bottom layer of your container. Then use the pliers to snap off the top of your highlighter. And then use them to very carefully pull out the sponge that's in the middle of your pen. This is what holds the highlighter ink. Use your fingers and the pliers to squeeze the ink into the container. You'll see that it starts to mix together with the ferrofluid. Place the magnet underneath the container and you'll see that it pulls the ferrofluid towards it. If we put this mixture under a black light, you'll see that it creates some amazing patterns. It looks particularly cool because the highlighter fluid glows in the dark and the ferrofluid doesn't, it just looks black. You can make this experiment even more interesting by snapping open a different coloured highlighter. For this version, we've used a pink highlighter. You can see that the colours mix together and create all sorts of weird shapes. To me, this looks like the surface of an alien planet. And up close, the area around the magnet looks like the eyeball of some sort of weird insect. This is a really unusual experiment, and one that you can have lots of fun with. You can try with all sorts of different coloured highlighters, a stronger or weaker light, and different sizes of magnet. Why not show this experiment to your friends and see who can create the strangest patterns? If you look very closely at the magnet, you'll see that it starts to separate the different colours in the ink. I can see blue, green, yellow, orange, red, even a bit of purple. And there you have it. That's how you can make glowing liquid metal. Hot ice. It's a really good one. You're going to need a conical flask, a thermometer, 30 millilitres of water, a pan, a spoon, 170 grams of sodium acetate, and a way to heat the pan. I'm using this electric pan. Place your pan on top of the surface, put the sodium acetate in the pan, and pour in your water. Use your spoon to mix the solution together. You want the pan to be warm but not boiling. enough to heat up the water without letting it boil. Stir the mixture together. You should see a few crystals still inside the solution. What you want to do is heat the water long enough to completely dissolve all the crystals. Once that's done, and while it's still warm, pour the mixture into your conical flask. It doesn't have to be a conical flask, but we found the shape of it helps in the experiment. Once you've poured all the mixture inside, drop some of the sodium acetate crystals into the mix and see what happens. An iceberg starts to grow inside the flask. This is a crazy chemical reaction, and if you feel the flask with the back of your hand, you'll see that it's very warm. This is because your sodium acetate starts to crystallize again. It's a fantastic experiment, and it's really strange looking. When's the last time you had hot ice? If we look at it from the side, you can see the crystals forming and spreading out. This is a really cool experiment. And that's how you can make hot ice. How to turn water into wine. You're going to need some plastic, some scissors, red wine, 2 wine glasses, and a bottle of water. The first part is to take your plastic. In this case, we've used an old DVD case. Take your scissors and very carefully cut out a square. It needs to be large enough to completely cover the top of your wine glass. Make sure that you have an adult to help you with this part. Once that's done, check that it fits. And then take your 2 wine glasses. You'll need to fill 1 glass with wine and 1 glass with water. Make sure that you fill both glasses right to the very top. Check that both of the glasses are equal. Then take your piece of plastic and very carefully place it on top of the glass of water. Hold it firmly against the top and turn the glass upside down. If you remove your hand, you'll see that the plastic stays there. Place the glass of water on top of the glass of wine and make sure that the edges of both glasses match up. Once that's done, very slowly pull out your length of plastic and leave a small gap on one side. You'll see that the wine starts to float upwards into the glass of water. Over time, you'll see that they start to swap places. What's happening here is really very simple. The water is heavier than the wine. So by leaving a small gap in the side, you're leaving room for the 2 to swap places. As the water falls downwards, due to its own weight, the wine has to rush upwards to make space for it. This means that very slowly they change place. As you can see at the very bottom of the bottom glass, there's a very thin layer of water underneath the wine. This is the water that's already collected. Theoretically, if you get the gap just right and gave it enough time, the 2 would almost completely swap places. Generally though, you'll find that some of the colour of the wine transfers to the water, making it that slightly reddish colour. It's easy to see the difference if you put something white in the background. After 10 to 15 minutes, slot your plastic back through to complete the seal. Carefully remove the top glass and flip it the right way round. Remove the plastic and compare the two glasses. You'll see that the glass that used to have wine in it now seems to be water with just a bit of wine, and the glass that used to have water in it is almost completely full of wine. And there you have it. That's how you can turn water into wine. Water well. This is a really easy experiment to do at home. All you're going to need is a large jar, a cardboard tube, some dirt, pebbles and coloured water. We've coloured our water with food dye. Firstly, take your jar and put the cardboard tube into the centre. Then very carefully drop some dirt around the outside of the cardboard tube. Once you've got about halfway up the jar, you can fill the rest of the space with your pebbles. Be careful that none of this gets inside the tube, because it's important that the inside stays as clean as possible. Then very carefully, pour your coloured water around the outside of the cardboard tube. If you observe carefully, you'll see that the water is soaked inside the cardboard tube, just like a well. In nature, after it's rained, the resulting groundwater is absorbed into the earth and is stored in the soil. Eventually, enough water is absorbed into the soil so that water pressure builds up. When we dig a well into the earth, this intense pressure forces water into the well, which allows us to reach the water and use it for ourselves. This is a great example of making a miniature version of something you find in the real world at home using really simple to find materials. Look at that! Isn't that amazing? And there you have it. That's how you make your very own water well at home. Water candle. You're going to need some plastic, a birthday candle, a glass of water, some matches, a pair of scissors, some vegetable oil, and some adult supervision. The first step is to strip the candle down by snapping the wax off of it, so that you're left with only the wick from the middle of the candle. Then take your glass of water and pour some oil into it. Because the oil is lighter than water, it will automatically float and gather at the top. Make sure that you've got a good thick layer of oil. Then take your piece of plastic, make a small hole in the middle, being very careful, and then push the wick of the candle through the hole. You might want to pinch the hole back together a bit around the wick to make sure that it stays still. Then, carefully place the wick on top of the oil. You'll see that the plastic helps it float in place. Then light a match and light the wick. What do you think is going to happen? Well, as you can see, it lights just like a normal candle. This is because when you light it, normally a candle would use wax as fuel, but instead it's using the oil. The piece of plastic holds the wick above the water, letting it get plenty of air. The rest of the wick sits inside the oil, which sucks it up and uses it to help it burn. And there you have it. That is the water candle experiment. A water bulge experiment. All you're going to need for this experiment is a plate, some screws, a glass, and a jug of coloured water. The first step is to pour the coloured water into the glass. Pour carefully, and what you want to do is try and get the level of the water right up to the very top of the glass. Make sure that the glass is sitting level in your plate. Then start dropping screws into the water. How many do you think you can drop in before the water starts to spill out? You can see that we've already put 6 screws in, and still none of the water has spilled out. I was amazed when I saw how many screws I could put into the water. You'll see that the water starts to bulge over the top of the glass. This happens because surface tension holds the water together. You can see that when I move the glass, on the right hand side some of the water starts to spill out. That's because the surface tension was broken. Why don't you see how many screws you can get into the glass, and then try and challenge some of your friends? I bet you'll win the bet. And there you have it. That's how you can perform your very own water bulge experiment. Bottle fountain. It's a really great experiment. All you're going to need for this one is some blue tack, a bradawl, a balloon, a plastic bottle, a straw, a pen, a funnel, and some coloured water to make this experiment a bit easier to see. The first step is to take your plastic bottle, to take your bradawl, and very carefully make a hole in the bottle about 2/3 of the way up. Make sure you have an adult to help you, as bradawls can be quite sharp. Once that's done, take your pen and pop it through the hole, just to make the hole big enough for your straw to fit through. Take your straw and place it through the hole, making sure that the bent part of the straw is on the outside. Once that's done, take some of your blue tack and put it around the straw, sticking it to the surface of the bottle. The important thing is that you create an airtight seal, as this is very important to make the experiment work. Once you're sure you've made a seal, you can always tidy the blue tack up a bit to make it look really good. This might take you a bit of time, as plastic bottles aren't very easy to stick to, but it's very important to the experiment, so stick with it. Once that's done, we can continue. Now you need to put your bottle into a sink or inside a tray, just to make sure that you don't make any mess. Then, using the funnel, fill the bottle almost full with water. Blow up your balloon, secure it around the neck of the bottle, and watch what happens. You'll see that all of a sudden the water starts to spray out through the straw. This is because the air trapped inside the balloon is escaping into the bottle, pushing the liquid down, and the only way for the liquid to escape is to go through the straw, meaning it creates a fountain. Isn't that great? You can make water defy gravity using nothing more than a balloon. You can always play with the straw a little bit to change the direction of the water. You'll see that the water flow stays pretty consistent. You can see that almost pointing straight upwards, the water continues to flow. It's only when the water level nearly disappears and mixes with air that it starts to spurt and spray. It's a bit messy, so you'll have to clean it up, I'm afraid. Then when the balloon runs out of air, the water stops spraying. And there you have it. That's how you can make your very own bottle fountain. Wacky water experiment that I think is really clever. All you're going to need to conduct this experiment is a jar of cold water, a jar of hot water, some blue and red food dye, a plastic card, and a dish. Make sure that one of your parents is around to give you a hand with this experiment. The first step is to pour the red food dye into the hot water jar, and then very carefully stir it around to mix the colour. Then use some of the blue food dye to colour the cold water. This means you'll have a jar of cold blue water and a jar of hot red water. Make sure that the water goes all the way to the top of the jar so that it's almost spilling out. The first step is to put your cold water jar inside your dish, then carefully cover it with the plastic card. The next step is to turn this jar carefully upside down. You'll see that the vacuum formed inside the jar holds the card onto the surface. Then have your mum or dad place the hot jar of water into the dish and carefully place the cold jar on top. You'll need to go around every side of the jar and make sure that the edges line up perfectly. Then get someone to very carefully pull out the card from in between the jars. As they do, you'll see that the water starts to mix, which forms a pinkish purple colour. As each of the jars mixes in with the other one, you'll see that the colour evens out completely. This is because the water is very slowly mixing all of its molecules together. Now try this. Take the jar of red hot water, place the card on top, and repeat the same steps. This time the blue jar is on the bottom and the red jar is on the top. Have someone very carefully remove the card from the middle, and this time you'll see that the jars don't mix. So why is this? Is it the colours? No, it's not. In fact, the hot water has a different density to the cold water. It's very slightly less dense than the cold water and so sits on top. When we compare them side to side, you'll see that the reaction is completely different. This is because the cold water in the first experiment is more dense than the hot water and so sinks straight through all the gaps between the molecules in the hot water. And there we have it, a really simple, really cool science experiment. Upside down water. This is a really interesting experiment. And all you're going to need is a ball of string, some scissors, 4 cups of water, tape, and a tray. In this experiment, I'm going to turn all of the cups of water upside down without spilling a single drop. And so can you. Let me show you how. The first part of the experiment is to take your tray and turn it upside down. Next, you need to take your ball of string and make 4 equal lengths of string. The lengths don't have to be exactly the same, but do try to make them as close as you can. I'm doubling mine up to make sure it's strong enough. Once you've made the first length, copy it 3 more times. Then lay them out side to side to make sure they're all about the same length. As we're using scissors, make sure you have an adult to help you. Great! Now that you've done that, we can get on with the experiment. What you need to do is lay 2 pieces of string across the centre of the tray so that their ends meet. They need to go from corner to corner. And then once they're in place, take your tape and secure it to the bottom of the tray. It doesn't need to look completely tidy, it just needs to make sure that they're stuck down firmly. Once you've done that, you can repeat the process with the other 2 pieces of string, going to the other 2 corners of the tray. Don't worry, we're nearly up to the fun bit. Once you're sure that they're taped down securely, you can turn the tray over then gather the 4 pieces of string together and tie them securely into a knot at the other end. You need to make sure that when you hold the tray up by the 4 strings, the tray is balanced horizontally. If you're not quite sure how to tie a knot, why don't you ask an adult to help you? Great! Now you've tied your knot and we're ready to continue. The next step is to take each of your 4 cups of water and place them evenly on the tray. Once you've done that, we're ready to go outside. Now that you're outside, make sure that all the water is still inside your cups. Go into an open space and swing the tray around. What do you think's going to happen? Do you think all the water's going to escape from the cups and the cups will fly everywhere? Well, as you can see, they didn't do that. And that's because of a force called centripetal force. You can see that all the water is still inside the cups and all of the cups are still on the tray. Isn't that great? Why not try it with more cups and see how many you can swing? And there you have it. That's how you can make your very own upside down water experiment. The travelling water trick. It's a great one to impress your friends with. All you're going to need to perform the experiment is scissors, coloured water, 2 cups, some string and some tape. The first step is to take one of the cups and fill it up with the coloured water. You can use any colour you like, in this case we've used blue. The next step is to cut a length of string, dip it into the water, just enough to get it wet, and then squeeze any excess water off. Then take the other cup and stick one end of the string into the cup using some tape. Make sure it reaches all the way down to the bottom of the cup. Make sure you get in there nice and firmly to make sure it stays attached. Then take the other end of the string and hold it inside the lip of the cup with your finger. Hold the cup with the water in it above the empty cup, but make sure it's not directly above, only at an angle. Also, you need to make sure that the lower end of the string doesn't touch the rim of the cup. Very slowly start to tip the cup of water over, and you'll see that it travels down the string. This happens because of a process called cohesion. Because the string is already wet, it's got lots of water molecules stuck to it. As you tip the water over, it finds the other water molecules and sticks to them, which makes it travel down the string. You'll notice that at first a little bit of water spilled out of the cup, and that's because it wasn't able to form a bond quickly enough to travel down the string. As you pour the water down, you'll find that you can actually pour it quite quickly, and that's because water likes to stick together. And there you have it. That's how you can get all of the water from one cup into the other without pouring it directly over. And there it is. That's the travelling water experiment. Tornado in a bottle. It's a really simple experiment, but loads of fun to do. What you're going to need is some glitter, a water bottle filled with water, and some washing up liquid. All you need to do is to remove the cap from the bottle of water, pour in some washing up liquid, just a few drops, and then add your glitter. You can add as many colours as you like, and as much or as little glitter as you want. Then make sure you securely fasten the cap back onto the bottle. All you need to do is put your bottle onto a tabletop and spin it round very quickly. When you let go, you'll see a vortex forming inside your bottle. Now this vortex forms because of the circular motion of the water. Vortexes can be found in tornadoes, whirlpools, and they can reach speeds of up to 300 miles per hour. Why not have a go making vortexes with loads of different colours of glitter? And that's how you make a tornado in a bottle. Bending water experiment. This is really simple. All you're going to need is a balloon. Firstly, stretch out the balloon to make sure it's easy to blow up, and then take a puff and blow it up. Once that's done, tie a knot in the end so the air does not escape. Then take your balloon over to a tap and borrow someone's hair. Rub the balloon against their hair and you'll see that their hair stands on end. Once it's doing that, take the balloon close to the tap of running water and see what happens. the balloon seems to attract the stream of water from the tap. This is because when you rubbed the balloon on your friend's hair, it picked up a charge of static electricity. Then when you hold the balloon close to the water, this electric charge attracts the water to it. This is because water is a conductive substance. Move the balloon closer and further away from the water and see how it affects the stream. Isn't that great? And there we have it. That is the bending water experiment. Underwater candle. You're going to need a knife, a long candle, a jug of water, a transparent bowl, and some matches. Don't forget, you'll need some adult supervision. Firstly, take your long candle and measure it against the side of the bowl. Use the knife to make a mark where the top of the bowl is. Once that's done, place the bowl to one side and very carefully cut into the candle. It's best to ask an adult to help you with this part. Cut through just enough so that you can split the candle in half, and then use the knife to cut through the wick. Make sure you still have a little left at the top. This should give you a short candle. Light a match and then light the candle. Once that's done, turn the candle on its side and drip some wax into the bottom of the bowl. This will help hold your candle in place. Stick the candle into the wax, hold it in place, blow the candle out, and let it sit for a few minutes. Then pour some water into the bowl. The water line needs to come all the way to the top of the bowl, so keep filling it up until there's no more room. The candle should just be coming over the surface of the water. Then relight the candle. Sit back and watch. This experiment takes some time, but we've sped up our video to show you it a bit quicker. Over time the candle will burn down, and then when it reaches the water line, the candle will seem to disappear. If you give it even more time, the candle will continue to burn. If you leave the candle long enough, the flame will go below the water line. The water around it will keep the sides of the candle cool and stop that wax from melting, which in turn forms a wall around the wick of the candle, stopping it from being put out by the water. Why don't you see how long you can get the candle to burn, and how low the wick can go? You could try it with thicker candles, or thinner candles. I think this is a really simple and fun experiment. And there you have it. That's how you can make your very own underwater candle, the lemon volcanoes. For this experiment, you're going to need some baking soda, some lemons, a knife and a spoon, dish soap, and food dye. The first step is to carefully remove the nib from your lemon. This will create a flat surface that allows it to sit still. Then cut the top off the other end of the lemon. And using your knife, mash up the insides of the lemon a bit. It's best to ask an adult to help you with this part. This experiment might get a little bit messy. but it just makes it more fun. Once that's done, add a small amount of food dye, an equal amount of dish soap, and then your baking soda. You'll see that things start to bubble up. If you use your knife to mix the three together, you'll see that colourful bubbles start to erupt from your lemon. You can repeat this again. This time try with a different colour. You could try mixing the food dye and the dish soap together, then adding the baking soda. In this experiment, I tried pouring a little bit of extra lemon juice on top to see what happens. As you can see, it very quickly creates more bubbles. What's happening here is that the baking soda is reacting with the lemon juice inside the lemons. The food dye helps us to create a more colourful explosion, and the dish soap helps the bubbles to stick together for longer. You can try placing some food dye around the edge of your volcano. See if it helps it to become more colourful. This is a really fun experiment because you can try it in all sorts of different ways with different colours. I think it looks really cool. You can repeat the experiment and put them all side by side. Have a volcano race and see which one erupts the quickest. Don't forget, you can add some lemon juice or some vinegar to the top. This will speed up your experiment. How to pick up ice with a single piece of string. It's really easy to do and really fun. What you're going to need is a piece of string, a small dish, some ice cubes and some salt. What you need to do is take your dish, put one of the ice cubes inside it, and then lay a piece of string across the ice cube, making sure that it's in contact with the ice. And here's a tip: try wetting the string before this experiment. Then sprinkle some of the salt on top. Once you leave it for about 30 to 60 seconds, if you lift the string up, you'll see it brings the ice with it. This is because when you sprinkled the salt on top of the ice, it started to melt it. The ice then started to refreeze, freezing the string on top of it. And there we go. Crazy, right? I bet you didn't think that would work. That's the trick to picking up a piece of ice with just a single piece of string. How to pierce a potato with a straw. Now this is a really simple experiment. All you're going to need is a potato, a pencil, a straw, and a knife. Make sure you're very careful when you're performing this experiment, because it does involve you trying to pierce the potato using several sharp objects. Make sure an adult is present when you're performing it. First of all, try with the knife. You'll find that even though you can get into the potato, you can't get all the way through. And now the pencil. The same thing happens. That's because the potato is quite thick and so resists. Now try with the straw. You'll find that it's very hard to pierce through the potato. I bet you don't think you can pierce the potato with just a straw, but you can. All you have to do is cover one end with your thumb. And there you see, the straw goes straight through the potato. This is because by covering the end of the straw with your thumb, you trap air inside. Then, when you push it through the potato, the air inside becomes condensed, creating pressure inside the straw that makes it stronger. And there you have it. That's how you pierce a potato with nothing but a simple drinking straw. How to make raining blood. It's a really creepy experiment and really fun to do. All you're going to need for this one is a bowl of oil, a jar of water, a fork and some food dye. The first step is to take your bowl of oil and add a few drops of each of the food dye. Make sure that each bottle of dye is a different colour. We've got some yellow, some green, some blue, and finally some red. You'll see that the food dye sinks to the bottom of the oil, so what you need to do is take your fork and mix it together. Once that's done, you simply pour the mixture into your jar of water. You'll see that, as usual, the oil floats on top of the water. But if you give it a few seconds, you'll see something very interesting starts to happen. Small droplets of the mixture start to fall to the bottom of the water. This is because the food dye and the oil mixed together is heavier than the water. They cling together in droplets. After some time, you'll see that some of the drops that have fallen to the bottom of the jar start to go back to the surface. This is because the food dye and the oil start to separate, the food dye going into the water and blending, and the oil floating back to the surface. Ugh, gross! And there you have it. That's how you can do raining blood at home, with no real blood needed. Shaving cream rain. This is a really messy and really fun experiment to try, and all you're going to need is shaving cream, food dye, and a jar of water. Very simply, take the jar of water, shake up the spray cream, and fill the rest of the space inside the jar with cream. Then, very carefully, dribble the food dye on top of the shaving foam. Some of it might run down the sides, but that's okay. If you look inside the jar to the water, you'll see that the food dye starts to seep through the cream. This is because it's much heavier and much denser than the shaving cream, and so eventually forces its way through and dribbles into the water, just like rain. This is a really cool experiment to show how rain clouds work. Once the food dye breaks the surface of the shaving cream, it starts to fall out just like droplets of rain. Isn't that great? You can try this with different colours of food dye and it will work just the same. And there you go. That's how you can make your very own shaving cream rain. The singing glass experiment. It's really easy. All you're going to need is a wine glass and a bottle of water, as well as some adult supervision. Take the wine glass and pour some water into it until it's about a third of the way full. Then dip the tip of your index finger into the water and gently rub your finger around the edge of the glass. Don't push too hard and don't do it too lightly. And very quickly you'll start to hear the glass sing. Isn't that beautiful? But why is this happening? Well, it's due to something that we call resonant frequencies. Everything in the world has its own resonant frequency. When you rub the glass, you put energy into it, which forces the molecules of the glass into vibrating and producing a noise. If you pour different quantities of water into the glass, you'll see that it changes the pitch of the noise. This is because it slows down or speeds up the vibrations. And there we go. That is the very simple singing glass experiment. Wrapper worms. What you're going to need for this experiment is a pipette, a straw with a wrapper, and a bowl of water. What you need to do is take your straw, tear off the wrapper at each end, and then very carefully push each end of the wrappers together so that it starts to crinkle up in the middle. This will squeeze all of the tiny fibres inside the paper together. Then very carefully slide the straw off of the wrapper. You're left with what looks like a tiny caterpillar made of paper. Then simply place the paper caterpillar onto the table and using the pipette, drop some water onto it. you'll see that the paper instantly seems to grow and move. This is because the fibres inside the paper start to absorb the water that you're dropping onto it, making the fibres expand and stretch. This then makes the paper seem to move. You can use this with a few different kinds of wrappers from different straws and see how they react differently. And there you have it. That's how you make your very own wrapper worms. A wacky whistle. For this experiment, all you're going to need is a glass of water, a straw, and a pair of scissors. Make sure that you have an adult present for this experiment. Very simply, all you need to do is take the straw and, using the scissors, make a cut roughly 1/3 of the way along the straw. Make sure you don't cut all the way through the straw, but just enough so that you can bend it in half. You'll see that you can bend the short section of the straw to about 90 degrees. This is perfect for your experiment. Very simply, place the long end of the straw into the glass of water and blow. The whistling sound is caused by vibrations in the air inside the straw. As you lower the straw into the water, there is less air inside, which creates a lower pitch. As you raise the straw, there is more air inside, which makes a higher pitched whistling sound. And there you have it. That's how you can make your very own wacky whistle at home. How to make a tornado in a bottle. It's a really simple experiment, but loads of fun to do. What you're going to need is some glitter, a water bottle filled with water, and some washing up liquid. All you need to do is to remove the cap from the bottle of water, pour in some washing up liquid, just a few drops, and then add your glitter. You can add as many colours as you like, and as much or as little glitter as you want. Then make sure you securely fasten the cap back onto the bottle. All you need to do is put your bottle onto a tabletop and spin it round very quickly. When you let go, you'll see a vortex forming inside your bottle. Now this vortex forms because of the circular motion of the water. Vortexes can be found in tornadoes, whirlpools, and they can reach speeds of up to 300 miles per hour. Why not have a go making vortexes with loads of different colours of glitter? And that's how you make a tornado in a bottle. How to create rising water. All you're going to need for this experiment is a glass cup, a lighter, a plate, a match, some coloured water and a coin. Since you're working with a lighter, make sure you have an adult with you when you do the experiment. Simply take your match, bend it in half, and weigh down the wooden end with your coin. Then pour your coloured water onto your plate. Pour just enough so that you've covered the surface of your coin, but not too much because you want to make sure that the match is still sticking out from the surface. For this experiment we've chosen some pink water, but you can use any colour that you like. What you'll need to do then is take your lighter, very carefully light the other end of the match, and quickly place your glass on top of the match. You'll see that instantly the water starts to rise up inside the glass. This is because the heat from the match starts to create a vacuum inside the glass. The liquid forms an airtight seal around the edge, and the vacuum inside sucks liquid into the glass. So there we have it. That's how you show how to make rising water. Raining blood. It's a really creepy experiment and really fun to do. All you're going to need for this one is a bowl of oil, a jar of water, a fork and some food dye. The first step is to take your bowl of oil and add a few drops of each of the food dye. Make sure that each bottle of dye is a different colour. We've got some yellow, some green, some blue, and finally some red. You'll see that the food dye sinks to the bottom of the oil, so what you need to do is take your fork and mix it together. Once that's done, you simply pour the mixture into your jar of water. You'll see that, as usual, the oil floats on top of the water. But if you give it a few seconds, you'll see something very interesting starts to happen. Small droplets of the mixture start to fall to the bottom of the water. This is because the food dye and the oil mixed together is heavier than the water. They cling together in droplets. After some time, you'll see that some of the drops that have fallen to the bottom of the jar start to go back to the surface. This is because the food dye and the oil start to separate, the food dye going into the water and blending, and the oil floating back to the surface. Ugh, gross! And there you have it. That's how you can do raining blood at home, with no real blood needed. Oxidization. For this experiment, you're going to need an apple, a lemon, and a sharp knife. Make sure that you have an adult present. The first step is to simply cut the apple in half, and then do the same with the lemon. Then cut the lemon in half again, giving you 2 slices. The next step is to take 1/2 of the apple and rub the lemon against it. Make sure that you get plenty of the lemon juice onto the surface of the apple. This will help the experiment to run properly. Put this piece of apple to one side and then place the other half in another bowl. Place the 2 halves of the apple side by side. You'll see that 1/2 of the apple has turned brown and the other half has stayed the same. This is an effect called oxidization. It's the same process that causes rust to form on metal. There's an enzyme inside apple which starts to turn brown on contact with air, but squeezing the lemon juice onto the apple does 2 things. First, it causes a small barrier to form on the outside of the apple, and secondly, the acid inside the lemon juice stops the enzyme from working, means that the other half of the apple doesn't go brown at all. And there you have it. That's how you can conduct a very simple oxidization experiment, avoiding pepper. It's a really simple experiment and you only need a couple of things to do it. For this experiment you need a bowl, some water, washing up liquid and pepper. Very simply, pour your water into a bowl, preferably something that's quite wide. Then sprinkle a lot of pepper onto the surface of the water. You need to make sure it's fairly well covered. Once you've done that, get your washing up liquid and place a very small amount onto the tip of one of your fingers. Then place your finger into the middle of the bowl. You'll see that the pepper seems to run away from your finger. Well, it's not the pepper that's running away, but in fact it's the water underneath the pepper. The washing up liquid on the tip of your finger reduces the surface tension of the water underneath it. This means that the pepper has to stay on top of the water with a higher surface tension, and so gets as much distance between it and the finger as it can. It's almost like magic, but it's science really. And that's how you demonstrate avoiding pepper, dancing raisins. Now this is a really, really easy experiment. All you're going to need is a bowl of raisins, a bottle of soda water and a glass. Very simply, pour some soda water into the glass, make sure that it's nice and full. You'll see that loads of bubbles are floating to the surface. The next step is to drop some of the raisins into the soda water, and instantly you'll see that they seem to be dancing. This is because the tiny bubbles of carbon dioxide inside the soda water are latching onto the tiny wrinkles on the raisins. The more bubbles that latch on, the more gas there is stuck to the raisins, and the more gas there is, the lighter they get, and so they start to float to the surface. When they hit the surface, some of the bubbles pop, which makes the raisins heavier again, and they sink to the bottom. This process then continues to repeat. And there you have it. That's how you really easily make your own dancing raisins. Diving ketchup experiment. For this you're going to need a bottle of water, a sachet of sauce, preferably ketchup. The first step is to take your bottle of water and your ketchup. Then unscrew the lid. Make sure that the bottle is completely full of water. And then very carefully insert the sachet of sauce into the bottle. You'll find that water spills out of the bottle when you do this, but that's fine. Once that's done, very carefully and tightly seal the bottle. You'll see that the ketchup packet floats inside the water. But if you squeeze the bottle, it sinks. Let go and you'll see that it rises to the top again. Why is this? Well, it's because inside the ketchup packet there is also a very small bubble of air. When you squeeze the bottle, you compress the air inside the packet, which makes it denser, and therefore it sinks to the bottom. When you let go of the water, you release the pressure, and it means that the air inside the packet becomes less dense, and so rises back to the top of the bottle. You can play around with this for a while and see how quickly you can make the packet sink and how quickly you can make it rise. If you get the pressure just right, you can make it float directly in the centre of the bottle. Why don't you challenge your friends at this and see who's best? You could even have a race to see who's fastest. And there we have it. That is the amazing diving ketchup experiment. Duck call at home. Now this is one of the easiest experiments we've ever shown you. All you need is a pair of scissors and a straw. First of all, start to flatten out your straw. This will become very important later on if you want to make a good duck call. If your straw has a bent side, make sure you cut it off. Then, very carefully, cut one end of the straw into a point. You'll see that the end has two pointed triangles, much like a duck's beak. All you need to do now is put the flat end of the straw into your mouth and breathe in sharply. The sound that you're hearing is caused by the pointed ends of the straws vibrating very fast together, creating a duck call. And there you have it. That's how you make your very own duck call at home. Motion on the ocean. For this experiment, you're going to need some baby oil, a funnel, some blue food dye, a bottle, and a jug of water. First of all, add some blue food dye to the water. Give the jug a bit of a stir, and then use the funnel to half fill the bottle with your blue water. You might find that doing this causes some bubbles to form on the surface of the water. If that happens, just leave it aside for a few minutes and they should go away. Then take your bottle of baby oil and very carefully fill the bottle the rest of the way with oil. Try to make sure there is as little air left in the bottle as possible. Once that's done, take the lid and fix the bottle securely. You need to make sure that none of the oil or water pours out. Then, very simply, take the bottle and turn it on its side. You'll see that inside the bottle you seem to have an ocean where the waves are churning and turning. This is because the oil and the water have different densities. They never mix together properly and so stay separate, with the oil floating on top of the water. Now this is a really cool experiment which demonstrates the difference between different densities of liquids. You can play with the bottle, turn it end to end or side to side, and see the way the waves take shape. And there you have it. That's how you make your very own motion on the ocean at home. Put out a candle without blowing it. Now this is a really fun experiment, and what you're going to need to do it is 1 candle, 1 tablespoon of baking soda, 1/4 cup of vinegar, a sheet of paper, a plastic bottle and some matches. What you need to do first of all is roll your paper up into a cone shape. Then place your cone into the top of your plastic bottle and pour in the baking soda. Be careful not to spill any. Brilliant. Once you've done that and you're sure all the baking soda is inside the bottle, take the cone out and pour in your vinegar. You'll see bubbles start to form inside the bottle. Then, take your candle and light it. Tilt it towards the candle. Get ready, kids, because this is amazing. You'll see the flame goes out all by itself. Wow, isn't that cool? It's just like magic. This happens because the carbon dioxide is heavier than the rest of the air inside the bottle, so that when you tilt it, the carbon dioxide comes out first and puts out the flame. This is because flames need oxygen to burn. And there you have it. That's how you can put out a candle without actually blowing it. Snake bubbles. All you're going to need is some rubber bands, a big plastic bottle, a pair of scissors, some white socks, a small plastic bottle, some food colouring, bubble mixture, and a glass. Firstly, carefully use your scissors to cut off the bottom of your large plastic bottle. It's best to ask a parent to help you with this, as the scissors may be sharp. Smooth off the edge of the bottle so there are no sharp pieces. Then take your sock and again use the scissors to cut along the end of the elastic part of the sock. Then carefully stretch the fabric of the sock around the bottom of the bottle. Pull it tightly so you create a sort of drum made out of material. Make this surface as tight as you can. Once that's done, use a rubber band to hold the sock in place. Next, pour your bubble mixture into a container. Make sure that the container is wide enough for you to dip the bottle inside. Take the bottle and dip the sock end into your bubble mixture. Make sure there's plenty of mixture on it. If you blow into the neck end of the bottle, you'll see that you create thousands of tiny bubbles. This is because the fabric of the sock has tiny holes inside, creating lots of little bubble blowers for you. Now, how can we make this more interesting? I've got an idea. What you need to do is take your food dye and pour some over the end of your bottle. You can do this in spots, in stripes, or you could just completely soak the end of your sock in food dye. I'm going to start with a little red and blue, just to see what happens. Let's cover a good amount of the surface in food dye. Once that's done, take a deep breath and blow. You can see that as the bubbles come through the sock, they soak up some of the food dye, creating coloured bubbles. This is a really fun experiment. You can try with all sorts of different coloured food dyes. You could even try different socks to see what gives you the best bubbles. And that's how you can make your own snake bubbles. Scary slime! Isn't that cool? For this experiment you're going to need 2 bowls, 1 teaspoon of borax, half a cup of PVA glue, a spoon, half a cup of water, another cup of water, green food dye and a Ziploc bag. What you need to do first is mix your teaspoon of borax with 1 cup of water. Use the spoon to stir the mixture until all of the borax is completely dissolved into the water. Keep on stirring. Then you need to get half a cup of water into your bowl. Add the green food dye. Get it right in there, enough to make it a really cool colour. And then add the PVA glue. Stir the glue into the water and the food dye mixture until it starts to swirl and you get a thick, gooey paste. You'll see that the colour is completely mixed in with all of the glue and the water. Then you take your borax mixture and mix it into the glue mixture. You'll see that it very quickly starts to thicken. Use the spoon to continue stirring the mixture until it gets thick enough to use your hands. Then use your hands to pull all the separate strands of goo out and separate it from the water using your second bowl. At this point, it should be really slimy and gooey. Disgusting! Make sure you get as much of the mixture separated from the water as possible. Did you know the PVA glue in the scary slime is called a polymer? When a polymer mixes with the sodium borate, or borax, they combine to produce one giant new molecule. This new compound is able to absorb huge amounts of water, which creates the slime. The first kind of slime was invented by accident in the year 1043 by James White, while searching for an alternative way to make rubber. Isn't that crazy? Take your Ziploc bag and very carefully pour what's left of the slime into the bag. Seal up the top of the bag. This will stop from making a mess. And then you can see your scary slime mixture. Singing glasses. This is a really cool experiment. And all you're going to need is 2 wine glasses, a cocktail stick and some water. Take your 2 glasses and put them very close together, but not quite touching. Then pour some water into one of the glasses until it's about half full. Then carefully pour water into the second glass until it matches the level of the first. If you go too far, you'll need to pour some water into the first glass so that it matches. Make sure you're completely confident that the water level is exactly the same. If you prefer, you can measure the water beforehand. Then take your cocktail stick and place it carefully on top of one of the glasses. Then wet your finger and rub it along the edge of the first glass. Can you hear the glass singing? Well, that's because that as you rub your finger along the edge of the glass, it causes vibrations, which in turn create sound. And as you can see, the vibrations seem to be working in the second glass as well, even though they're not touching. Well, this is because the water level is the same in both glasses, and so their vibrational frequency is the same. When another object picks up the same vibrations as the first, we call this a sympathetic vibration. These tiny vibrations not only create sound, but movement as well, and that's why the cocktail stick seems to move all by itself. And there we have it. That is the amazing singing glasses experiment. the soda can jump. This is a really fun one. You're going to need mug number 1, mug number 2, and a soda can. You're going to need to empty the soda can. Once you've done that, place the can inside one of the cups and blow into the cup. You'll see that the can jumps out. You'll also see that this works regardless of which way round you put the can into the cup. Place the second cup close to the first and blow. Try and aim the can into the second cup. Why does this happen? Well, the can is very light. When you blow air into the space between the cup and the can, it creates an area of high pressure. This high pressured air forms underneath the can and pushes it. The air above the can is still at a low pressure, and so the can is able to move based on the air alone. Why not move the cups around and see what you can do? Challenge your friends to see who can score the most points. And there we go, that is the soda can jump. Wrapper worms. What you're going to need for this experiment is a pipette, a straw with a wrapper, and a bowl of water. What you need to do is take your straw, tear off the wrapper at each end, and then very carefully push each end of the wrappers together so that it starts to crinkle up in the middle. This will squeeze all of the tiny fibres inside the paper together. Then very carefully slide the straw off of the wrapper. You're left with what looks like a tiny caterpillar made of paper. Then simply place the paper caterpillar onto the table and using the pipette, drop some water onto it. You'll see that the paper instantly seems to grow and move. This is because the fibres inside the paper start to absorb the water that you're dropping onto it, making the fibres expand and stretch. This then makes the paper seem to move. You can use this with a few different kinds of wrappers from different straws and see how they react differently. And there you have it. That's how you make your very own wrapper worms. Water well. This is a really easy experiment to do at home. All you're going to need is a large jar, a cardboard tube, some dirt, pebbles, and coloured water. We've coloured our water with food dye. Firstly, take your jar and put the cardboard tube into the centre. Then very carefully drop some dirt around the outside of the cardboard tube. Once you've got about halfway up the jar, you can fill the rest of the space with your pebbles. Be careful that none of this gets inside the tube because it's important that the inside stays as clean as possible. Then very carefully, pour your coloured water around the outside of the cardboard tube. If you observe carefully, you'll see that the water is soaked inside the cardboard tube, just like a well. In nature, after it's rained, the resulting groundwater is absorbed into the earth and is stored in the soil. Eventually, enough water is absorbed into the soil so that water pressure builds up. When we dig a well into the earth, this intense pressure forces water into the well, which allows us to reach the water and use it for ourselves. This is a great example of making a miniature version of something you find in the real world at home using really simple to find materials. Look at that! Isn't that amazing? And there you have it. That's how you make your very own water well at home. Do-it-yourself projector. You're going to need a cardboard box, a magnifying glass, some gaffer tape, a scalpel, a pair of scissors, and a pencil. The first step is to use the scalpel to remove one of the flaps from the box. When that's done, take your magnifying glass and hold it against one side of the box. Use the pencil to carefully draw around the magnifying glass. Use the scalpel to carefully cut out the circle shape. It's best to ask an adult to help you with this part of the experiment. Make sure to be careful when using the scalpel. Once you've cut out the circle, fit the magnifying glass into place. You might be able to remove the handle from yours. We couldn't, but that shouldn't affect things too much. Use some of the gaffer tape to secure the magnifying glass in place. This creates the lens for your projector. Then, take the piece of cardboard that you cut off earlier and fold it up to make a stand for your phone. Check that your phone fits securely onto the stand. Once you've done that, load up a video onto your phone. You'll need to change your phone settings so that the screen doesn't rotate, and then place the phone so that the video plays upside down. When the image transfers through the magnifying glass, it will be turned around the right way. Take the box into a dark room and there you go. The image is projected onto the wall, and you've got your own cinema at home. You'll need to try moving the phone around into slightly different positions and angles in order to get the clearest picture, and it's never going to be as clear as it is at the cinema, but it's still a really cool trick that you can do very easily at home. And there you go, that's how you can make your very own do-it-yourself projector. Homemade mini lightsabers. This is a really cool experiment. You're just going to need some differently coloured LED lights, some watch batteries, 2 clear plastic pens, a black marker and some gaffer tape. The first step is to unscrew the pen from its clear case. Then take one of your LEDs and wrap it around the sides of the watch battery. You'll know if it's the right way round when the light starts to glow. Take some of your tape and secure the LED light in place. Wrap the tape all the way around to make sure that it's secure. This will also form the handle of your lightsaber. Place the clear lid over the top of the LED light, and then use a bit more tape to fix that in place. Once that's done, you can use your black marker pen to decorate the handle of your lightsaber. Have a look at some of the ones they use in the Star Wars films, or you could try and make your own. I've decided to add some stripes to mine. And don't forget, you'll need to draw on a few buttons. Once that's done, repeat the process with the other LED light. And when you're finished, you'll have 2 lightsabers. Let battle begin! And there you have it. That's how you can make your very own homemade mini lightsaber. Magic mud from tonic water. All you're going to need is a spoon, some corn flour, a bottle of tonic water and a bowl. Pour some tonic water into the bowl. About 500 millilitres will do. Then add a few tablespoons of corn flour. You'll need to add enough so that it forms a thick paste. You'll notice it's very hard to mix together, but stay with it and you will manage it. It starts to form quite a gluey consistency. You'll notice that the mixture starts to behave quite strangely. You can pick it up like a solid object, If you apply pressure to it, it behaves like it's solid, but as soon as you remove the pressure, it behaves like a liquid. If you place it in the palm of your hand, you'll see that it runs straight through your fingers. This strange fluid is something we call a non-Newtonian fluid, which means it doesn't follow the normal rules of how a liquid should behave. You'll also notice that it can get quite messy. You can do this just with normal water, but there's an added benefit to using tonic water. Tonic water contains a substance called quinine, which glows in the dark. So if you apply an ultraviolet light, you'll see that your magic mud glows in the dark. This is a great experiment to do with friends. You can see who can make the best magic mud. You could try adding some food colouring to the mixture to see if it glows a slightly different colour in the dark. And there you have it. That's how you can make magic mud from tonic water. The silver egg illusion. For this experiment, all you're going to need is a pair of tongs, an egg, a glass of water, a lighter, and a candle. The first step is to take your candle, take your lighter, and light the candle. Make sure that you have an adult present when you're doing this. Once the candle is lit, you're ready to go on. Take your egg and hold it carefully using the tongs. Hold the egg just over the tip of the flame. You will need to get the egg nice and close to the flame to make sure this works. When you're close enough, you'll see that a thin black layer of soot forms around the outside of the egg. Do this all the way around the egg, coating as much of it as you can in a layer of black soot. Once that's done, take your glass of water and slowly place the egg inside. You'll see that the egg suddenly looks like it's made of silver. Well, this is actually because the soot that coats the outside of the egg is really a thin layer of carbon, which repels water and holds a very thin layer of air around the outside of the egg, making it appear silver. The areas not coated in soot look completely normal. Isn't that amazing? It's a great illusion to show your friends. Why not have a competition and see who can make the most amazing looking egg? And there you have it. That's how you can perform the silver egg illusion. Twist in time experiment, which is really great fun. You're going to need 4 clips, a glass and a smaller glass, 3 different types of food colouring, 3 small tubs, 3 pipettes, some liquid hand soap, a jug of water, and some adult supervision. The first step is to take your larger glass and add a small amount of liquid hand soap. Then take your smaller glass and place it inside. Do this slowly so that you don't add too many air bubbles to the mixture. You'll see that the hand soap starts to run up the inside of the larger glass. Then fill the small glass with water. This will help to weigh it down and hold it in place. Take one of your clips and place it onto the rim of the larger glass. Take another clip and place it on the opposite side. Place a third clip and leave a space for the fourth. Then take your 3 tubs, pour a small amount of hand soap into each of them, then add a few drops of food dye into each tub. 2 worked well for me. Make sure that none of the food dye gets mixed up. Then use your pipettes to mix the food dye in with the hand soap. This might take some time to do properly, but it's well worth it once it's finished. Again, make sure that the pipettes do not mix. Take your glasses. Very carefully use the pipette to suck up a few drops of the food dye and soap mix. Then, very carefully, place the pipette into the layer between your large and your small glass. Go about 1 inch down into the soap. Squeeze some of the mixture into the liquid and pull it out again. Make sure that you're very careful as you do this. Repeat this step twice, once with each colour. Try to remove any air bubbles from the pipette before you squeeze out the mixture. This will help the experiment go much more smoothly. You'll see that as you squeeze the mixture out into the soap, it forms a small pool and then remains. This is because the soap is very thick. Try to hold the glass very still as you do this. Once all 3 colours have been placed, put your last remaining clip into its spot. Then, very carefully, turn the inner glass. You'll see that the 3 colours start to blend together, almost disappearing. That's the end of that, isn't it? Well, perhaps not. Turn your glass back in the opposite direction, and you'll see that the colours come back. They haven't mixed together at all. But why is this? Well, we're still not quite sure of the exact reason ourselves, but the best explanation is that when you put the 3 colours into the mixture, they actually form 3 separate layers, each on their own. When you turn the glass, each layer is spread out thinly. When you turn the glass backwards again, the layer returns almost to normal, but they never mix. Isn't that great?